The MCAT loves to take a system that works perfectly and break it and then ask you what happens.
Jason, welcome back to the MCAT podcast. How you doing, my friend?
I'm doing great. How are you?
I am excellent. I'm licking my wounds from not remembering rest and digest soon enough with the parasympathetic nervous system. Rest and digest for everyone out there. Remember, parasympathetic, rest and digest. Let's talk about discrete section, because we're going to jump into a biochem discrete here in this Blueprint MCAT half-length diagnostic. It's always a mouthful. BlueprintMCAT.com. Go there, get access to this diagnostic for free. Discrete sections, very different, I think, in terms of like mindset, in terms of comfort level. I have less of a crutch to be able to go back to a passage and potentially extract some information that's going to help me answer a question. The discrete section for me is make or break. I either know it or I don't know it. Is that the right thinking, or is there some potential logic involved here as well?
Oh, yeah, absolutely there is. So some of these questions are going to be certainly just content, just kind of like a science class final. You're going to see a bunch of that. But there are going to be a lot of, so the AMC has these divided up into different skill numbers. So skill 1 questions are those just basic, do you know the content, recognize a term, apply a term, that kind of thing. Skill 2 questions are the more reasoning-based questions. And skill 1 and skill 2 both represent about 40% of all of the questions each that you're going to see on your test. And by and large, your discretes are going to be one of those two. So you are going to see skill 2, some reasoning questions in the discretes, where you're asked to apply something that you know to a new situation. A lot of the psych-social questions are going to do that, where they say, here's a vocabulary word. Which of these is a person that's exemplifying that vocabulary, is doing something in their day that is that thing? Or conversely, here's a person who's doing something. Which of these vocabulary words is the descriptor for what they're doing? So seeing those more reasoning-based questions is not uncommon for the discretes.
Okay. So 100% fear not warranted, maybe 40% fear.
And in fact, it's actually a little bit less scary, because you never have to sit there and wonder, like, was there something relevant in the passage that I need to include in this?
Yeah.
So you have, like, it cuts out half of all of the potential sources of information, the other half being your brain, where, you know, it's going to be based in something I know. I don't have to go back to a passage. I don't have to scan for information. I don't have to worry if like this one phrase provides me the information I needed to answer the question.
Yeah. So here's a strategy that I hear every once in a while on Reddit is I recommend you go to all of the discrete questions first. Just like click through all the passages, get to the discrete questions, answer those first. Do you have any strategy suggestions in terms of that?
I get the rationale behind that. If you do easier questions first, they often go much more quickly than more difficult questions. And it gives you a better sense of your pacing once you're trying to go through those more difficult questions and how much time you have allotted to spend on them. So I get the rationale. Also, being able to get those quicker points can help to build some momentum, build some confidence. But you have to balance that against the fact that you're clicking through the section ultimately to find them. And you don't have a really good way of finding those discrete sections just from the navigation page. The navigation page doesn't tell you where the passage sections begin and end. So you are clicking through 59 questions to be able to find the discrete sets within the section, which is going to take more time than I think you're going to save in the long run.
Okay. All right, let's go ahead and jump into our discretes today. I'll read the first one here. Which of the following, this is question 29, again from the Blueprint MCAT Half-Length Diagnostic, which you get for free at blueprintmcat.com by creating a free account. Question 29, which of the following is most likely to use a protein channel to cross the eukaryotic cell membrane? A, aldosterone, B, C8-2+, C, O2, or D, CO2? All right. So, protein channel, cell membrane. What's going to use a protein channel to go there?
So this is one of those questions where, again, you could sit and make your flashcards and memorize like all the different things that can go through the cell membrane and approach it that way.
Yep.
And that, I think, is what a lot of people do when they're studying for this test.
Yep.
The other direction to approach this from is from a reasoning perspective.
Yep.
And you can say, well, what do I know about cell membranes?
Yep.
And what does that tell me about the kind of stuff that can go through it and what can't?
Yeah. Cell membranes are there to help protect us, keep things out and put things in and transport things, get things to the nucleus where we need them and to all the different parts of a cell and blah, 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 blah. So, I mean, potentially is this another one of those, like our last episodes, like which one of these is not like the other, where we had insulin being a really big molecule going, well, that's not going to use this thing, and the other ones were really small ions or whatever. I mean,
all else being equal, yeah, we can do that here.
Yeah. So again, aldosterone kind of stands out to me because it's a big hormone here. That's like, is that the same as these ions, as O2, as CO2? I mean, to me, like if I were doing this, and I am doing this, and going, okay, like aldosterone's different than everything else here, then that's the one that I'm gonna say potentially is the one that's gonna need. The other potentially ways to think about this, as I'm looking at it, is like, okay, protein channel, cell membrane. Let's look at charges. The only one that has a listed charge is answer choice B at Ca2+. Now, are they just leaving off charges off of O2, CO2, or are those kind of not charged positively or negatively? Is aldosterone charged negatively or positively? I don't remember. And so I'm left with answer choice A or B for those two reasons. Either because aldosterone is very different than the other three, and so it needs to use that, or we need to use B because it has a charge and the cell membrane wants to regulate things with charges, and so that's going to happen. I'm going to go with answer choice B just because I'm like, let's go with something a little bit different this time instead of shape, size, whatever, because we need hormones getting into places to do things. Do we want to regulate that, or should we regulate charges to make sure we're not blowing up cells because we have too much charge going one way or another?
Don't want that.
Yeah. So I'm gonna go with B.
Okay, so B turns out to be correct here.
Okay.
B is the correct answer. So, so that heuristic that we have for like one of these things is not like the other, and I'm going to use that to select an answer, that works really great in a pinch. Here's a situation where more than one of these answer choices is unique in some way.
Yeah.
So just saying, all right, aldosterone is a larger molecule, the rest are small, and see, especially because that's answer choice A, and that's the first thing that we see, it's a lot more likely that we're going to select that one, and therefore a lot more likely that we're going to get this one incorrect. Mm-hmm. So what I was alluding to before about cell membranes, when you think cell membrane, you should be thinking phospholipid bilayer. Like that's the thing that's important. So forget the context here. Hydrophobic and hydrophilic come up a ton on the MCAT.
Yep.
They come up in protein folding. They come up in cell transport, like we see here. They come up in chemical reactions, solvation layers and soaps, things like that. So we're going to see that idea throughout the MCAT, and being able to spot it here with the cell membrane on all right, what's going to be able to go through from one side of a cell membrane, which is an aqueous environment, through the phospholipid bilayer, that lipid in the middle that is a little bit more oily, a little bit more hydrophobic, and then out through the other side. So the sorts of things that can go through the bilayer are things that are perfectly happy going through a hydrophobic environment. So oxygen is small and it's nonpolar. CO2 is small and it's nonpolar. Aldosterone is a little bit larger, but it's a steroid hormone. And steroid hormones are based in cholesterol. And cholesterol is one of the things that is perfectly happy to not only be incorporated into a cell membrane, but pass right through it. Ions, on the other hand, are really going to hate that hydrophobic environment in between the inside the cell membrane. So ions need special channels, special ways of getting through.
Yeah. Oh, I don't like these questions.
It's okay. It's okay. So, like if you're practicing and you get a question wrong, don't automatically assume it's because I didn't study enough.
Uh-huh.
It comes down to like, what could I have noticed that would have been maybe a larger trend that I can apply to more questions. So I bet the next time you see a question on cell membrane and you're thinking hydrophobic in the middle, it's like a water Oreo where, water on the outside, hydrophobic lipids in the middle. That tells us a lot about what we would expect to see with the behavior of things trying to go through.
Yeah. All righty. Let's have you read next question here. Question 30.
All right. Which of the following is an element of humoral immunity? We've got A, phagocytes, B, immunoglobulins. That's a tongue twister. C, T cells, and D, MHC1. How are you feeling about immunity?
I mean, everyone should know about immunity with COVID, right? We all have gotten our re-education on the immune response and Omicron and all the variants and what's working, what's not working. The humoral response. Oh, man. So let's try to see if I don't remember what humoral means, if we can see what's going on here. Immunoglobulins, T cells, phagocytes, MHC1, which I don't remember what MHC stands for. So we'll just have to hope that that's not the right answer.
So do you have a gut feeling about any of this?
The gut feeling is, why am I doing this to myself? This test called the MCAT is terrible. So, I mean, the one thing that is different without remembering MHC1, phagocytes and T cells are these kind of things out there. If we think about the immune system, we have like B cells, T cells, the phagocytes, right, that are out there doing all this stuff. Immunoglobulins, I think of like antibodies and things that are going on. And to me, that's just, there's something different about that for some reason. I don't know why. And like, I'm like, versus like phagocytes and T cells, maybe a little bit too similar in my mind versus, I have no idea. I'm going to go with B and I'm going to move on.
Your instincts are 100% correct on this one. And that's awesome. So this is a question where it is, that skill one, that content-based, you know it or you don't. And it comes down to familiarity with the different divisions of the immune system and being aware of the large pieces of each one. We don't need to get down into the nitty gritty of exactly how the immune system works for this question. We just need broad strokes. But that's what the MCAT rewards. The MCAT rewards a breadth of knowledge, not necessarily a depth of knowledge. So your instinct here that phagocytes and T cells are more similar than they are different is 100% correct. Those are part of cell-mediated immune response, where those are actually the cells that are going out and doing the thing. And in fact, MHC1 is the target protein for T cells. It's one of the two, so there's MHC1 and MHC2, one of the two kinds of proteins that will latch onto a pathogen that T cells recognize and then attack. So all three of those are part of the cell-mediated immunity. We've got innate immunity, which is the stuff that just like is your skin, saliva, stuff like that. And then immunoglobulins, which you said, and I'm still 0 for 2 on pronouncing that correctly, which you said are like antibodies. That's exactly what they are. And those antibodies are released by beta cells. So it's not the beta cell that's doing the thing. It's the stuff released by the thing that's doing the thing. It's all very technical terms, but that's what we mean by humoral immunity. We're using humors. We're using some other fluid or what have you that goes out and
is
does
that what humoral comes from? Like
I think so. I could be 100% wrong about that, but it feels right to me.
Like out in the ether, we would talk about the humors of the body. We didn't know anything.
You got your phlegm, you got your bile, you got your blood, you got the black ichor.
That makes complete sense, and now that's going to stick in my brain even more.
Man, finding these little things to latch onto is the best thing. It's not flashcard knowledge. It's like a little bit of taking that piece of knowledge that you're trying to get and putting it on a hook in your brain.
Yeah.
That really makes the difference. If you can relate it to something you already know, you'll never forget it.
Yeah. So it's like, is the thing doing the thing itself, or is the thing having something else do the thing? And
is it the henchman or is it the dictator that's sending out the henchman?
Yeah. Got it. Okay. Got it. Random. All right, little tidbit. Hopefully people can hang their hat on that one. Question 31, last one here in this short little discrete section. A molecule enters a cell and creates pores in the inner mitochondrial membrane. Will oxidative phosphorylation continue to generate ATP? A, yes, because the cell membrane is still complete. B, yes, because ATP is required for cell function. Okay. C, no, because there is no available oxygen. Or D, no, because the proton gradient will be dissipated. So I'm going to immediately throw out answer choice B, because that's not really answering the question. It's like, yes, ATP is required for cell function, but that's just saying like the obvious. So I'm gonna get rid of answer choice B to hopefully increase my chances here. We're gonna poke holes, aka pores, in this mitochondrial membrane. To say that the membrane is still complete, like, I don't know how that can be true. Like, sure, like the wall was built, but when you build doors into the wall, like things can still happen. It's not complete. I don't know. Like, so I'm gonna get rid of A, because to me that's just weird. Like, it has holes in it. I don't know if you can say that's complete. And so I'm left with C and D, both no answers. So no, because there's no available oxygen. And so I'm like, well, why is there no oxygen just because we have pores? Because I would assume there's still oxygen, like whoever's body this is, they're still breathing. Hopefully they have lungs. And
Although if this happens not for long,
yes, everywhere. And so I'm just going to go with D because it seems like it's the most obvious answer to go, well, if you poke holes, then we're disrupting our homeostasis and things are going to be all screwed up. And so I'm just going to say D.
absolutely right. Yep, D is our answer here.
It seemed too easy, but it was so weird.
Yeah, there's no such thing as too easy on the MCAT. So there will be gimmies on the MCAT.
473. 473.
Yeah. I mean, it's on a normal curve, so we're gonna see those. That question is a really great example of the sort of thing that we have been talking about, especially in that last passage that we did, where the MCAT loves to take a system that works perfectly and break it, and then ask you what happens. And this proton gradient in the mitochondrial membrane is one of those things. If we dissipate the proton gradient, then we don't get all that lovely electron transport that ultimately leads to ATP.
Yeah.
So that knowing that connection between the proton gradient and making ATP answers a lot of these kinds of questions for you, and you should expect to see a small handful of questions on oxidative phosphorylation on your test.